This is an introduction video for the night driving simulator LucidDrive. In this video, you will learn the basic operations and basic functionalities. LucidDrive is a night driving simulator with an emphasis on the simulation and visual analysis of headlamp light distributions. LucidDrive complements Lucid shape design tools by enabling you to analyze automotive headlamps with various road scenes. It provides a virtual reality in which to perform simulations prior to expensive fabrication and testing. During a simulation, you can switch quickly between different lamps, viewing positions, road types, and scenes and receive immediate interactive feedback. LucidDrive runs in an automatic driving mode without the need for interactive controls such as steering, accelerating, or braking. We will begin with the explanation of the fundamentals of LucidDrive to understand the behavior of the software. Here, the light flow from the source to the observer, the light scattering on surfaces, and the drive curve are described. After the fundamentals, you will guide through LucidDrive to learn the program layout, the configuration, and road libraries. Afterwards, you will set up a simple headlamp example to examine the light pattern. During this example, you will also learn how to add other road users and apply adaptive front lighting systems. Let us start with the fundamentals of LucidDrive. In order to get a basic understanding of LucidDrive, it is important to know the flow of light from the source to the observer. The process can be described as follows. The light that is emitted by the headlamp is represented using an intensity distribution. The intensity distribution file contains information about the luminous flux in a certain angle. You can use different file formats for the intensity distribution, such as the native Lucid shape format LID, or other formats like IES or CSV. LucidDrive then uses the intensity distribution to calculate the illuminance pattern on the surfaces of the environment. Each surface has assigned to it a bidirectional reflectance distribution function, BRDF, which determines how the light is scattered from that surface. LucidDrive calculates the luminance observed by the driver by combining the lux pattern created by the sources, the BRDF of the surface, and the relative directions of the emitting sources and the observer. Next, the luminance distribution must be displayed on the screen. From the observer's perspective, a luminance image is created. The 3D scene is converted into a 2D scene according to the observer's view. Then the brightness of each pixel is calculated. Considering all light sources, 256 tone values are assigned to a specific luminance range. The brightness value is also applied to the color pixel of a bitmap texture. For example, a red pixel on a car will appear bright red when it is heavily lit, and dark red when it is dimly lit. The scattering behavior of the roads are specified by two bidirectional reflectance distribution functions and determine the outgoing luminance pattern based on incoming luminance. The diffuse BRDF type determine the diffuse surface scattering. The specular BRDF type is responsible for forward scattering. The default BRDF type represents a Lambert scattering distribution and can be applied for the most common road surfaces, such as concrete or asphalt. The Lommel-Seliger BRDF type, based also on a Lambertian scattering, and considers a dependence on the observation angle, and is a good choice for light scattering of very dark and very rough surfaces, such as cobblestones. The Hoffmann and Nakata scatter models were developed by the measurement of road surfaces and consider particularly flat viewing and illumination angles. The scattering models Hoffmann and Nakata may only be used for the driver's view. Other views such as bird's eye view give incorrect results. In addition to the diffuse scattering, you can also define the forward scattering portion of the road surface. For this, the Cook-Torrance model will be used. This scatter model is a physical model in which the surface is modeled by many small reflective facets. The Cook-Torrance scatter model is a simplification of the Gaussian scatter model, and is therefore very suitable for real-time computer graphic animations. Using the parameters in this dialog box to determine the ratio of the diffuse BRDF scattering. The parameter mean roughness allows you to change the width of the scattering lobe to model the roughness of the surface. A high value models a rougher surface, a low value a smoother surface. In addition to the scattering properties of surfaces, the appearance is also enhanced by bitmap textures. Bitmap textures influence the luminance and color information of the surface, and thus enable the creation of a realistic roadway and environment. Bitmap textures are used in the road editor during the road generation process. You can use common bitmap data files, such as BMP or JPG. On the right you can see different bitmap textures for road surfaces, side green, or signs. You can also create road users such as pedestrians, animals or trees in LucidDrive by using bitmap textures. So that vehicles, headlamps, and view positions can be guided along a specified road lane, a drive curve is required. This curve is specified when creating the course of the road in the road editor, and is located at the center of each lane. Based on the drive curve, vehicles, headlamps, and view positions can be shifted with offset values. In the images on the right, you can see two examples where different drive curves have been selected. In the bottom image, the drive curve of the right lane was selected. So, the view position is oriented along the right lane. In the example of the top image, the drive curve of the right passing lane was selected. Therefore, the view position is located on the passing lane. In LucidDrive, you can choose the drive curve in the Scene menu. After the fundamentals have been explained, we can now set up a simple example in LucidDrive and run a driving simulation. Start LucidDrive. The program layout consists of 4 parts. The entire scenery of the driving simulation is shown in the primary view. In this view you can examine the light pattern of your headlight. Errors, warnings, and status information are displayed in the message view. In the menu bar above, you have access to all commands and can use them to create your required driving simulation or edit an existing one. From here you can, for example, load road scenes, adjust headlight settings, define driving behavior, or add road users. The toolbar on the left allows you to start and stop the driving simulation, and you can switch between different views. LucidDrive comes with a configuration library that allows you to load an existing configuration. Open configurations from the menu bar. A configuration is a native Lucid shape data format that contains the specified parameters of the entire scenery, such as headlamp settings, viewing position, color mapping, and the road scenery. For demonstration purposes, we will use the default file and close the dialog at this point. Click Roads in the menu bar to open the road library. With this library, you can load predefined sceneries. You are not restricted to use only the tracks from the road library. A software, called Road Editor, which is automatically installed with LucidDrive, enables you to create new road courses, including side green, trees, side markers and signs. Here are a few examples of predefined tracks. Scroll down to Downtown RHT. This predefined scenery is a course through a city with many intersections and lane lightings. Keep scrolling to USA country. This scenery includes a country road course with US road signs. A circular course does not always have to be used. Endless straight routes can also be created and used. Scroll to endless straight. The vehicle in this scenery will always drive on a straight lane without interruption. For demonstration purposes, we will use the default file and close the dialog at this point. In the next step, we will set up a headlamp for our example. From the menu bar, select Headlamps. There are 4 lamp sets by default. For our example, we will use only a low beam and high beam. Therefore, delete the lamp set for low plus high, and fog by clicking the X on the right. Click Apply. With the mounting position, you specify the positions of the right and left headlamp. H defines the height above ground, W the distance between the 2 headlamps. The center is on the drive curve position, in our case the center of the right lane. With the selection buttons, you can load the light intensity distribution file separately for the left and right headlamp. For demonstration purposes, we will use the default selected files. Under Options, you have the possibility to modify the headlamp. For example, you can adjust the spectrum of the headlamp here. XY chromaticity defines the color in the CIE color space. Predefined values for a halogen lamp, xenon lamp, or LED are available. You can also fit the color space yourself under Custom. Select Color Temperature to specify the light source color temperature according to the Planckian locus. The option SPD Fit function enables you to define a spectral power function with values. For demonstration purposes, we select XY chromaticity and sample halogen. Click Apply and close the Options dialog. In the Headlamps dialog, click Apply and close the dialog too. Open Visual Properties from the menu bar. As explained in the fundamental section, here you can edit the scattering functions of the road surface. If a dialog is displayed too large, you can collapse it. To do this, click the arrow above the relevant section. In the luminance range box, set the check mark at Fix Range and click Apply. This sets the luminance range for the entire scenery and makes it easier to compare headlamps with different luminance. Close the dialog. Maximize the primary view to use the full screen to display the scenery. In the toolbar, click the green flag to start the driving simulation. You can stop the simulation by clicking the red traffic light. Click the green traffic light to continue the simulation. To start the driving simulation from the beginning, click the green flag. The toolbar offers you the opportunity to quickly change the view perspective with one click. Change from the driver's perspective to the 20-meter view by clicking the corresponding icon. Switch to the bird's eye view by clicking the icon. In the bird's eye view, you can zoom into the view with the mouse wheel. Switch back to the driver view. In the headlamp dialog, we already assigned the light datasets to the headlamps, and it contains a low beam and a high beam. To switch between the light patterns, open Lamp Switch from the menu bar. Set the radio button to low beam to turn on the low beam pattern. Select high beam to turn on the high beam. The low beam is automatically turned off. Deactivate the check mark to be able to switch all lamp sets individually. Check the box of low beam to activate the low beam pattern again. Uncheck high beam to turn off the high beam pattern. You can close the dialog. LucidDrive offers additional options to check the pattern of your headlamp. From the menu bar, select Visual Properties. To get access to the collapsed parameters, expand the relevant section by clicking the arrow. Click on Illuminance to expand this section. Check the box next to Show Isolux Lines and click Apply to display Isolux lines to the scenery. In the coloring box, select False Color and click Apply to switch to a false color display. Select Lamp Color again and click Apply to use the correct spectral data and close the dialog. Another analysis option is the using of an aiming wall. With this you can display the light distribution on a wall in the front of the car. To do this, open Scene from the menu bar. In the aiming wall section, check the box Show to add a wall to the scenery. Important lines are already displayed by default. Since we are using an ECE low beam, the lines for SAE and fog can be deactivated. The lines help you to adjust the beam pattern correctly to avoid glaring. Deactivate the aiming wall in this dialog to get a clear view of the road again. Also in this dialog, you can add two types of distance markers to the scenery. In the distance marker box, set the radio button to marker. In combination with Isolux lines, the marker enables you to check illumination distances along the road. Change to 20 meters view for a better overview. Select Grid to also examine the width of the illumination. You can adjust the grid size with the parameters on the right. Please note that the marker and the grid are located a few centimeters above the road. On uneven roads, it can happen that the markers are below the road surface and are therefore no longer visible. Set the radio button to off, to switch off the marker lines. For a more realistic representation, we will now insert vehicle geometries in the scenery. Click the selection button at the top of this dialog, and navigate to your LucidDrive installation directory. Open the LucidDrive folder. Then the folder Vehicles. In this folder you will find various vehicle geometries that you can use in LucidDrive. Select the geometry Mercedes E. Click Open. In the toolbar, change the viewing perspective to driver view. Now we are looking from inside the vehicle to the road. In the next step, we will add several road users to the scenery. Also in this dialog, click the Create button 3 times, so that 4 vehicles are listed. Select the vehicle 2 in the list of the dialog. Click the Selection button. Select the geometry Audi Q7. Click Open. On the right of the dialog, you have the option to specify the position of the selected vehicle. You can use the pull-down menu to determine the driving lane for the vehicle. We will keep left lane. The parameter Offset allows you to move the vehicle from the default starting position. Enter 50, to move the vehicle 50 meters along the road. Click Apply. Furthermore, here you can determine the driver perspective position. Also apply geometries for vehicle 3 and 4. Select vehicle 3. Click the Selection button. Select the Forward Probe geometry. And click Open. Enter an offset of 350, and click Apply. Select Vehicle 4. Click the Selection button. Select the Skoda Superb geometry. Click Open. Enter an offset to 650. Click Apply. The 3 added vehicles are on the opposite lane, because the drive curve parameter is set to left lane. Select the vehicle 1 to use our original vehicle, and close the dialog. Open the lamp switch dialog from the menu bar. Check the box High Beam to activate the high beam headlamp. With the help of the Isolux lines, you can see clearly that the oncoming drivers will see glare from your headlamps. In the next step, we will create an adaptive front lighting system AFS example, which enables an automatically dimming of the high beam. To realize an AFS, you must add a plugin to LucidDrive to control the headlamp. A plugin, also called script, based on a source code program. With a text editor, you can create new or edit existing script files related to your headlamp and road scenery. Open the AFS menu from the menu bar. This dialog allows you to use different adaptive front lighting systems in LucidDrive. For example, swivel, matrix, or pixel light headlamps can be simulated. For our example, scroll downwards in the list and select AFS High Dim V2. Check the box Use AFS. The selected AFS script is listed on the bottom of the dialog. Close the dialog. Drive for a while and see how the high beam dims automatically. In the next step, we will also assign a light distribution to the other vehicles. Open headlamps from the menu bar. The list shows all the vehicles that we recently added. Select Vehicle 2 and click Add New Set. In this example, we will only assign a low beam light dataset to all vehicles. Click the selection button in the LID left column. Open the LIDS folder in the LucidDrive installation directory. Select the file ECE and click Open. Then click the selection button in the LID right column. Select the file ECE and click Open. Click Apply. Do the same settings for Vehicle 3 and 4. Select Vehicle 3 and click Add New Set. Click the selection button in the LID left column. Select the file ECE and click Open. Then click the selection button in the LID right column. Select the file ECE and click Open. Click Apply. Select Vehicle 4 and click Add New Set. Click the selection button in the LID left column. Select the ECE file and click Open. Then click the selection button in the LID right column. Select the ECE file and click Open. Click Apply. Select Vehicle 1 to use our original car, and close the dialog. As already mentioned, you can switch between driver view, 20 meters view, and bird's eye view in the toolbar. LucidDrive is not restricted to these three views and offers additional perspectives. In the menu bar, click Cameras. Additional views are the pedestrian view and drive-by view. Set the radio button to pedestrian view to look to the front of the car from a pedestrian perspective. Select drive-by view to view the car from different positions and drive for a while. Select the upper view. This corresponds to the 20 meters view from the toolbar. On the right, you have the opportunity to change the view position. Close the dialog. After all settings have been made, the entire setup can be saved as a configuration file. This enables you to use the model including all vehicles and settings at another time. In the menu bar, click Configurations. Click Save Config File. Select a suitable directory, for example the config folder in the LucidDrive installation. Choose a meaningful file name, such as First Example, and click Save. Afterwards, you can find our saved example in the list of the configuration library. In the first example, you learned how to add vehicles and determine the positions on the road. In this case, the added vehicles are on the same drive curve and have the same maximum speed, acceleration, and cornering speed. This means that all vehicles are driving one behind the other, and there is no overtaking. LucidDrive offers you the option to simulate a more realistic traffic situation. With the traffic simulation, you can assign speeds and accelerations to vehicles individually. The different speeds ensure that overtaking processes will take place at some points. Let us now extend our first example model for a traffic simulation. In the menu bar, click Roads. Due to different vehicle speeds, overtaking processes will take place in the scenery at some points. Therefore, it is necessary to choose a street that contains 4 lanes. 4-lane roads and motorways from the road library are suitable roads. Scroll down the list and select 4-lane track, A. Click Load selected road. If a road is used that does not match the traffic simulation, you will receive a message in the message view. Open Traffic Simulation from the menu bar. After loading the road, the scenery still contains our 4 vehicles and their settings. The 4 vehicles are already present in the dialog. To add more vehicles, you can set the number in the box next to number of vehicles. You can assign 2 to 120 vehicles for traffic simulation. We will take the default number of 20 and click Apply. On the right side you can see that 20 vehicles have been added. The vehicles are randomly assigned geometries from the Vehicle Geometry pool. In this pool you can add more or delete selected geometries. Also, driving parameters, such as speed and acceleration, are assigned randomly to the vehicles. However, you have the option to change the driving parameters for each car separately on the right. Close the dialog. Start the driving simulation by clicking the green flag. No light datasets have been added yet to the 16 additional vehicles. As already shown, you can do this in the headlamps menu. To do this, select the vehicles from the list and assign a light data file to them. In our example, we will not do that and close the dialog again. We will now also save this example as a configuration. Click on Configurations in the menu bar. Click Save Config File. Select a suitable directory, for example the config folder in the LucidDrive installation. Choose a meaningful file name, such as second example, and click Save. You will now find our saved second example in the configuration list. You can close LucidDrive. This training video showed you the basic functionalities of LucidDrive. You are now able to add headlamps to the scenery, modify them, and switch various light patterns on and off. The presented analysis tools such as isolux lines, aiming wall and distance markers, as well as different view perspectives, enable you to check the quality of your headlamp in a realistic environment. Furthermore, you learned how to add several road users and the generation of a traffic simulation to create a realistic traffic situation. Thanks for watching.